No coherence, no fringes. So let's unlock the most important as well as puzzling condition of the interference of the two waves. So in this question, we are going to discuss if the two waves have to be coherent in order to produce fringes, then what factors make those two waves coherent? So let us investigate. I will completely show you comprehensively by drawing the wave, and I will show you that if the two waves are coherent, then not only it means that their frequency is constant, but also it means that their phase difference is also constant. If you take at any point and you calculate the phase difference at any given point, you will get a same value, which makes the two waves coherent and they are able to interfere. So constant phase difference. So it means that its answer should be the frequency should be same and the phase difference should be constant. But let us see. So for example, if the two waves are if the basically the one monochromatic wave, and I'm showing you the wavefronts and the distance between them is a one wavelength, is passing through the two slits. So the two by passing through the two slits, these waves will be diffracting without any change in their wavelength. So when it will diffract, so you see that these two waves, which are monochromatic, are interfering with one another at some given points. At these given points, at some points they will do interfere constructively, and at some point they will interfere destructively. And hence, what pattern do we get? We always get a bright spot due to the constructive interference in the middle, and then we get a dark spot due to destructive interference. Anyways, these are the overall generally idea of the fringes. Between any two consecutive bright fringes, we have a dark fringe that is also called minima. Now, dear students, understand this idea concept that these two wavefronts, which are passing through the two slits, these wavefronts, they have a same wavelength. They will maintain the same wavelength between them. So this is also the lambda, just like this is a lambda wavelength. So it means it is monochromatic. So which means that if the wavelength has not changed, it means the frequency is obviously will remain same. So in that way, they will interfere with one another. But this point is tricky. That what is an exact mean of phase difference is constant, that I will going to show you exactly in this section. Not only that, I will also explain you the path difference. So let's draw the first wave. So that is going to be like this. This is a one wave that is going to interfere with another wave. As I told you that they have a same wavelength, which means they have a same frequency, like this. Now notice that their path difference is zero, which means that they will interfere constructively, and you see that their crust and crust overlap with one another as well as the trough and trough. Now let's talk about the phase difference, which is important in our case. So this is 0 degrees, this is pi, this is 2 pi radians, and then this is 3 pi radians. And in the same manner, we have here the pi, here we have a 2 pi, and here we have a 3 pi. So if, for an example, you take a phase difference between these 2 points, so what is that phase difference? So phase difference will be 0, and that will remain 0 at all the points at any given point on the two waves. Even if you take a phase difference at that point, so the phase difference, what is a phase at that point? It is obviously we have 1.5 pi. Here we have a 1.5 pi. So when you will take a difference, we will have once again 0 phase difference. But let's say if there's another wave, although the two waves have a same frequency, but I am taking intentionally, I'm going to start this wave from here. So now I'm intentionally producing a phase difference because I want to show you that it is not necessary that the two waves which are producing a constructive interference will always have a phase difference zero. It is not necessary. Why? Because if you consider this point, this is zero. For this wave, it is pi. This is 2 pi. This is 3 pi. And this is 4 pi. Now compare the first wave with the third, this wave. I'm going to consider the interference between these two waves. So now notice this is pi and this is 3 pi. Take the difference of these two. So when you will take a difference of these two, so what is answer? 2 pi. Now take a difference of any other. What about 2 pi and 4 pi? Take a difference of these two phases. So you will once again get the same answer, 2 pi. And it will remain as it is. But if this wave will not have a constant frequency, which means that it is something like this, okay, now the phase difference will obviously change. It means that it is important that the phase difference must be constant. That makes the two waves a wave coherent. Last but not least, kindly consider the interference between these two waves, the wave 1 and the wave number 4. Because in these two waves will produce a destructive interference and hence produce a minima or a dark spot on a double slit interference pattern. So what do we see in this case, dear students? So this is 0, this is pi. So now kindly see, once again, see this point. This is pi, and corresponding point for this wave, the angle is 4 pi. So if we take a difference between the 4 pi and pi, so it is 3 pi. It means that at all the points, the phase difference must be pi, and we see exactly, yes, it is true what we see from here. And secondly, kindly notice the path difference. The path difference is 1.5 pi, means 3 pi over 2, which is a condition for a destructive interference. So these conditions and all of the information, I hope, is useful for you to understand now what factors make the two waves coherent so they can interfere and produce constructive and destructive interference. The one is a frequency must be constant, same, and the phase difference must be constant as well.